This is section 6.4. This is part 1 of rational exponents. And our objective of this section, this whole section, is going to be to simplify expressions with rational exponents. And this key word right here, rational, is simply another word for fraction. So now we're going to be able to write powers as exponents. Okay? So, a couple of things that we're going to go through here with the essential understanding is you can write a radical expression in an equivalent form using a fractional or rational exponent instead of a radical sign. Okay? In general, this is the most important thing here. The nth root of x is the same thing as x to the 1 over n power. Okay, for any positive integer n. Like the radical form, the exponent form indicates the principal root. Okay, now, what you're going to end up doing is you're going to end up converting back and forth from root to fractional exponent or rational exponent and rational exponent to roots. Okay, a couple of things that we want to clarify here, and this all is what goes into this here as well. Okay, notice again as you rewrite these, if I were to give you the nth root of a to the first. Okay? In order to write this, this is going to be a to the power of whatever's underneath the root divided by the index. Okay? It's always going to be the power on top, the index on the bottom, which is why you'll notice as we look at this here, the square root of 36, remember your index is 2, 36 is to the first power, so this is 36 to the power of 1, since 36 is to the first power, over the index of 2, so this is really 36 to the 1/2 power. On the cube root, it's the same type of concept, 64 again is to the first power, so this is 64 to the 1/3, 1 is the power of 64, the 3 is the index, the index always goes on the bottom. And then finally, the third example, the fourth root of 16. 16 is to the first power, that goes on top. The 4 goes on the bottom. So this is really 16 to the 1/4 power. Okay. So what you're going to have to be able to do is convert from radical form to exponential, and exponential to radical. You're going to have to be able to go back and forth. Okay. All right. So if the nth root of a is a real number, m is an integer, and m divided by n is in lowest terms. Again, as you look here, these are the same things going the other way. If I have a fractional exponent, I can create it as a root. Remember, the top number is the power of the base. The bottom number is the index. Okay? All right, let's take a look now at some examples. First, being able to simplify expressions with rational exponents. A couple of directions here first. First thing you want to do is convert from rational exponent to radical form. So you're going to have to be able to convert it to a radical. Then simplify the radical, which the radical part we've done before. We've already simplified that. Okay, so as we look at the first example, we have 216 to the 1/3 power. So I want to write that as a root. So this is going to be the third root of 216, or 216 to the first. Now, if you have your exponent chart there with you, remember we want to break this down and match this to the root here, the index. So 216 is the same thing as 6 to the third. And you'll notice my root and my exponent will cancel out, and all I'm left with is a 6. Okay? So you can be able to convert from exponential to root and root to exponential. Again, you're going to have to do it both ways, and we're going to show you those other ones later. So, example B, 7 to the 1/2 power is the square root of 7 to the first. Again, you don't necessarily need to write the 2, but you could if you wanted to. And 7 to the 1/2 is the square root of 7. So, the square root of 7 times the square root of 7 is the square root of 49, which simplifies to 7. Okay? So, being able to convert from rational exponent to radical to simplify. Okay? All right, now we're going to have to be able to also convert between both forms here. Convert from exponent to radical and radical to exponent. So let's take a first example. Okay, what is x to the 3/7 in radical form? Well, this happens to be, as I look at this, remember this is the root. X goes as the base. The bottom number is the index, so the 7 goes here. The top number is the power, so the 3 goes there. So this is the 7th root of x cubed. And in this case, there's no simplifying to do because you can't simplify that anymore. Okay. Example number 2, what is negative 3.5 y to the negative 3.5 in radical form? Okay. First thing we want to do here, as we look at this, we want to convert decimal to fraction. So negative 3.5. Negative 3.5. If I put that over 1 and I want to move this guy to the right, that means I have to move that to the right to get rid of the decimal. So this is really negative 35 over 10. And if I reduce that, they're both divisible by 5, it becomes negative 7 halves. So this is really y to the negative 7 halves power. Now, if you remember from the past, we cannot leave our root or our exponent as negative. Okay? So, in order to convert this into radical form, we have to make this 1 over y to the 7 halves power. And then 7 halves is going to be 1 over the square root of y to the 7th. Now, normally I would tell you you can't leave that. And the reason you can't leave that as your answer is because it has a radical in the denominator. But all they want you to do here is change forms. So you're not going to have to simplify that anymore. Get it to where you have a radical in it, and then you're done. Okay? So, third example, what is the square root of a to the 5th in exponential form? So, again, this is going to be the base of a. The power goes on top, and the root goes on the bottom. So we have a to the 5 halves power. Okay? What is the 5th root of b to the 3rd in exponent form? Again, have a b is the base. The root goes on the bottom, and the exponent goes on the top. So it's b to the 3/5 power. Okay, so what we've been able to do here in the first part is to be able to change forms from exponential to radical and radical to exponential, and being able to simplify some of these once we change forms. Okay, this concludes 6.4 Part 1. Don't forget to take a look at 6.4 Part 2 as well, and then you'll also have a WSQ.